Alright, in this video, we're going to kind of introduce a little bit about rate, and really taking this as an expansion of what we've already talked about with division and with fractions. Both of the concepts, we're going to talk about speed and we're going to talk about money, and both of these are pretty important as far as 8th grade standards go. So I want to reference back to an example we used in the division video. I talked about if I have a loaf of bread and it's 18 inches wide, and I have 6 friends coming over for dinner, and I want each of them to have the same thickness of bread, then I need to divide that 18-inch loaf of bread into 6 equal segments. And say, okay, well, how wide should each segment be? Say, okay, well, let's see here. If I divide 18 into 6 equal groups, well, 6 times what equals 18? Well, 3. So if I divide 18 into 6 equal groups, each loaf of bread, 0 to 3, 3 to 6, 6 to 9, are going to be 3 inches long. Well, the same concept applies to rate. Let's say that I drove 18 miles in 6 hours, and I want to figure out how far I drove in each hour. I'm going to say, okay, well, it was 18 miles in 6 hours, and now it's important to mention we're talking about if I was driving at the same speed the whole time. Okay, well, let's divide that 18 miles, or 18, into 6 equal segments. And I say, okay, well, each segment is 3, so that means each hour 1, 2, 3, 4, 5, 6, I drove 3 miles, then another 3, then another 3, so I was driving 3 miles each hour. And this is sort of how we define rate. We say, okay, well, then I drove 3 miles per hour. For every hour, I drove 3 miles. Great. And this is just reiterating, it's the constant rate, right? If I was speeding up and slowing down, it would be much more difficult, because it would depend on where I was. But assuming I was driving the same speed, I'm on the interstate, I've got cruise control on, then each hour I will have driven 3 miles. So another example, if I drove 60 miles in 4 hours, well, how fast did I drive each hour, assuming I was driving at a constant speed? Okay, well, let's break that 60 up into 4 equal segments. How long would each segment be if I divided 60 into 4 equal parts? Well, let's see, 4 times what equals 60? Not 10, that's 40, it's going to be bigger than that. 15. 15, it's a clock, right? 15, 30, 45, 60. Okay, so each hour I drove 15 miles, or 15 miles per hour. And we can kind of illustrate this using the cancellation property of fractions. If I have 16 over 40, that's the same thing as 15 groups of 4 over 1 group of 4. And so since we're talking about the same size groups, I can just say 15 over 1, or 15 miles per 1 hour. So I give a couple other problems, the same concept. I'll do 1. 100 miles in 5 hours. Well, let's break 100 up into 5 equal groups, and that means each hour I will have driven 20 miles. We can apply the same logic to money. Let's say that instead of an 18-inch loaf of bread in 6 equal segments, let's say that I have an $18 loaf of bread, and I cut it into 6 equal segments. What's the value of each slice? Okay, well, if the entire size of the bread's $18, then I need to break that into 6 equal parts, which would be 3, right? 3, 6, 9, 12, 15, 18. It means each slice costs $3. And so let's say I have a box of soda that's $4 and there's 12 cans inside. Well, what's the cost of 1 Coke? Well, we're being asked to divide 4 into 12 equal segments. So, okay, well, this gets a little bit tricky because 4 is smaller than 12, so it's not quite as easy. So I'm looking for, okay, well, how else could I break 4 up? Or if I needed to have, 12 here, so let's move on. I could say, okay, well, let's think about this. If I broke 4 up into, if I divided 4 into segments of 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then now, I've kind of divided this $4 so that each dollar is broken up into 3 segments. So I have a total of 12 segments. Now that I've divided 4 by 12, what's the length of 1 segment? Well, it's 1/3, right? Because, well, there's 3 segments in 1, so one of those segments, or 1/12, because there's 12 Cokes, that's 1/3, or 1/3 of $1, which would be 33 cents if you wanted to think about it in the sense of decimals. So I give a couple other examples. If a box of chocolate is $16 and there's 8 pieces, well, if I break 16 up into 8 parts, each part's going to be $2, right? Or if a bag of candy is $4 and there's 20 pieces, okay, well, I need to figure out somehow how could I break 4 up so that there's 20 segments. 4 times what is 20? Oh, it's 5. So each $1 is going to be broken up into 5 segments. And I say, okay, well, what's the cost of 1 candy? Well, if it's 1/5. Well, what is 1/5 of 1? Well, we can just say 1/5 of $1, which would be totally acceptable. Or you may want to get fancy and say that means each piece of candy is worth 20 cents. And I go on through a few other examples. So this is just kind of showing how rate is the same thing as fractions. It's division. There's nothing new here. But we are applying it to more kind of 8th grade concepts and putting it to real life. And hopefully bringing it to real life adds a little bit of excitement to it. And we realize that it's pretty easy to determine this kind of stuff just using the same properties of fractions that we've been using so far this year. Thanks a lot.